This is section 10.6 in your textbook. These are rational application problems involving what we call work. So there's different types. This textbook has a lot of different types. We're going to focus on what we call work problems. These are the easiest ones, and believe it or not, these word problems are easier than almost anything else we did in the chapter. So it's actually a pretty simple process once you learn how to set it up. So example 1 says, Melissa can clean the house in 4 hours, and her husband Zach takes 5 hours to clean the house. And how long should it take them to clean the house if they were to clean the house together? So ideally, if Melissa takes 4 hours by herself and Zach takes 5, if they were going to work together, it should take them less time. So pretending there's no bickering or disagreements, it should take them less time. The best way to set this up is the way the textbook does it, which is with a chart. With this chart, the top box is just kind of a placeholder. You can kind of shade that out. What you're going to have is the time in the middle column, and then what we call the rate on the side. You're going to have person A, whoever that might be for the situation, person B, whoever that might be for the situation, and then what we call the together time. So we're trying to figure out how long would it take them if they work together. That's the part we don't know. So we're going to call that X. Person A can be Melissa for this example. She takes 4 hours to clean the house. Person B would be Zach. He takes 5 hours to clean the house. And their rate is their per hour work. So if Melissa takes 4 hours to clean the house, assuming everything is perfectly mathematical, which we know it's not, but we have to pretend that it is, she would be done with 1/4 of the house per hour. So the first hour she'd be done with 1/4, and then 1/4, 1/4, 1/4, and in 4 hours she would be done. So the way we think about this is 1 over time. So we can write that down. Rate for these simple problems is 1 over the time. Same thing for Zach. If he takes 5 hours to clean the house, he would be 1/5 of the way through per hour. And the together rate works the same way. It'll be 1 over X. So we use the time they give us in the problem to set up these rate ratios. And the way it works is the first person's rate plus the second person's rate equals the together rate. So once you see this a couple times, it's really not so bad. So 1/4 plus 1/5 equals 1 over X. Melissa's rate plus Zach's rate equals their together rate. From here, we can solve for X. So to solve for X, we need to get a common denominator between 4, 5, and X, or an LCD. 4 times 5 is 20, and then X. So the first fraction needs to be multiplied by 5X over 5X. The second one needs to be multiplied by 4X over 4X. Don't forget the X, that's easily forgotten. And then the fraction with just X needs to be multiplied by 20 over 20. That way, they all are 20x on the denominator. As we saw in the previous videos, once all the denominators match, we can ignore them. And we have a pretty simple equation to solve here. It will be 5x plus 4x equals 20, which is 9x equals 20 divided by 9. So X, or their hourly, however long they would take working together, is 20 over 9 hours. And 20 over 9 sounds kind of funny for these real life application problems, so we can divide that out. 20 divided by 9 to get a little over 2 hours. So 2.2, so that's about 2.2 hours working together. So assuming they don't bicker, which husbands and wives like to do, but pretending they work perfectly together, that's how long it would take them working together. So let's go over that one more time. You put time in the middle column that's given in the problem. And then you have, sorry, let me get this situated. Then you have the rate, which is 1 over the time. The rate is what makes up your equation. The rate of the first person plus the rate of the second person equals the together rate. You set it up as a rational equation. You make a common denominator, which for these is pretty simple. Ignore the denominators and solve. Pretty straightforward. If you feel comfortable, go ahead and try example 2. If not, follow along again. So it says Alyssa can prep the animal shelter in 3 hours. Bill can do the same job in 2 hours. How long would it take if they worked together? So again, this chart is very helpful. You'll get used to it. Some students don't need the chart anymore, but I really like it. I like organizing things in charts. It makes it easier for me to see. So person A for this example is Alyssa. Could be a person or a thing. Machines can do the same thing. Person B or thing B would be Bill. And this is always the together. So some examples are 2 motors working together or 2 pumps working together. It's the same idea. So Alyssa takes 3 hours. Bill takes 2. We're trying to figure out how long they take if they work together. Alyssa's rate would be 1/3. Bill's rate would be 1/2. The together rate would be 1 over x. So my equation is 1/3 plus 1/2 equals, equals 1 over x. So that would be an LCD of 6x. So we're going to multiply this one by 2x over 2x. Multiply this one by 3x over 3x. I did not give myself enough space. And most importantly, this last one has to be multiplied by 6. Very easily forgotten about that last one. Now they all have 6x on the denominator, so we can ignore that. And that gives us, sorry, my pencils are going everywhere here. We get 2x plus 3x equals 6. So 5x equals 6 divided by 5. Which are usually pretty easy to solve. X equals 6 over 5 hours, which is kind of silly. If we do 6 divided by 5 in the calculator, we get 1.2 hours, which is easier for us to see. So you can write it as a mixed, improper fraction, or as a decimal, whichever makes more sense. So these 2 examples, they give you the time of the individuals, and they want the together time. Now that's true for this one as well. They give you the time of the individuals, they want the together time. Now we're going to work the second 2, same process, just a different unknown. So this example 3 says if it takes Liz 15 hours to repaint the interior of a house by herself, with her brother Jason's help, they can get it done in 6 hours. How long would it take Jason if he had to work alone? So the setup is the same, time in the middle, rate, person A, person B, and together. Everything sets up the same. You're just missing a different piece of the puzzle. So Liz's time is 15. Jason's time is unknown. Their together time is 6. So Liz's rate is 1 over 15. Jason's rate is unknown, 1 over x. And their together rate is 1 over 6. You still add the 2 individual rates to get the together rate. That is still the same setup. So 1 over 15 plus 1 over 6, and you want to give yourself some space. Plus 1 over x equals 1 over 6. So between 6 and 15, a good LCD would be 30. You can multiply 6 times 15, I think it's 75, but they can both multiply to 30. It makes it a little bit easier to work with. So I'm going to multiply the first one by 2x. Again, don't forget about that x. And then multiply the middle one by 30. And the last one by 5x. So you have to make those LCDs with the coefficient and the variable. Now that they all multiply to 30x, I can ignore the denominators. And I get 2x plus 30 equals 5x, and I get to solve for x. Should get x equals 10 hours. So Jason would take 10 hours to repaint the house by himself. Don't always get nice numbers, but for this one you do. Alright, I encourage you to pause the video and try example 4 on your own, see how you do, and then play it back to see if you got it right. So it says Alan can word process a research paper in 6 hours. With his coworker Steve's help, they can get it done in 4 hours. How long would it take Steve if he worked alone? So same setup, time and rate. Person A is Alan this time. Person B is Steve, and they're together time. Alan takes 6, Steve we don't know, together they take 4. So 1 over 6, 1 over x, and 1 over 4. And then my equation would be 1 over 6 plus 1 over x equals 1 over 4. A good LCD for this one would be 12. X, you can also use 24, that's not too bad. 12 is your smallest, that's all. So I'm going to multiply this one by 2x over 2x. Multiply this one by 12 over 12. Multiply this one by 3x over 3x. Now that they all match, I can ignore the denominators. 2x plus 12 equals 3x. Move the 2x over, and x equals 12. Nice and simple. So it would take 12 hours if Steve worked alone. So again, if you can get the setup, which is the same every time, and remember how your rates add together to build your equation, these are pretty easy. I would say no factoring, so no restrictions, none of that. It makes it much easier to work through.